Hey all, a little bit of time lapse for you, and boy do we have some weather. This is a lot of stratocumulus and higher altocumulus clouds riding up on the low-level jet. And I wanted to talk a little bit about clouds because let me see if I can bring back some of that footage that we just saw. Let me find a good spot here. But you can see how, let me find the right frame here. Yeah, you see this here? There's actually two layers. There's this stuff here, and then there's this higher stratocumulus layer. This is actually stratocumulus formed from the spreading of cumulus. So what's happening is, earlier in the day, these cumulus clouds are building up, and then they're hitting a mid-level inversion, and they're spreading out. So we're getting about 80% coverage from this higher stratocu and a little bit less from the root clouds there. Let me see if I can get one better look at that. Yeah, you can see a little bit of it right there, the lower cloud, and then above that, the higher cumulus. And this lower cloud here is at about, let me switch off this overlay here. There we go. Yeah, this lower layer is at about 4,000. This is up at about 6,000. And then there's higher layers on top of that, up at about 7,000 or 8,000. And you can see maybe a little piece of that a little bit later. Let me see if I can bring that up real quick. Yeah, see that right there where the sun is starting to peek out? Right up there. There's some higher, I would say, altostratus or maybe a little bit of virga up there. And kind of what I'm trying to do is teach you how to be kind of cognizant of cloud types, because that can factor into your interpretation of SQTs and soundings. And I'll show you a little bit about this stuff on the Fort Worth sounding in a bit. But one good reference you can check out is the WMO International Cloud Atlas, especially Volume 2. I would suggest going and putting WMO International Cloud Atlas Volume 2 and put that in there, and you'll get a very cool PDF there. And these atlases used to be super expensive. They were like $200 or so. And nowadays, thanks to the internet, you can get them free of charge. And just to give you a quick look at the inside, they show all the different cloud types here, for example, cumulonimbus calvus and so on. And what we had out today was a little bit further down. Yeah, that looks familiar, doesn't it? Looks a little bit like what we had. Stratocu, higher layer, and then cumulus underneath it. And we can see cumulus and stratocu with bases at different levels. And it actually gives you a cloud type, low cloud type 8. And we can look that up on a plotting chart and get the symbol for that. In fact, let me go back for a second. Actually, this is a low cloud 4 is what we have. Because what we have is from the spreading of cumulus rather than two separate clouds, which would be cloud type 8. So cloud type 4, yeah, this is what we had out today. Stratocu formed by the spreading out of cumulonimbus. And then you can see this other one, cloud type 8, is not by the formed by the spreading of cumulus. So that's just some cloud stuff. We used to keep in all the weather stations I worked at, we kept a copy of this WMO Cloud Atlas, and we would browse through it from time to time to kind of get familiar with all the different cloud types, and I would definitely recommend checking that out. And this is where you can get it here. This is the WMO International Cloud Atlas site, which is very neat, and they've actually got the Volume 1 too. And they've got little flowcharts in here for finding the cloud types. And I'm kind of sad that, with all the automation we have these days, we don't have ceilometers that will differentiate cloud types anymore. So some of the stuff is starting to go away. We're only looking at qualitative stuff like cloud amounts, cloud base heights, and that's it. But there are still some stations that do report cloud types in the synoptic observations, and you can plot those on some of your surface charts sometimes. We're not showing it here, but some stations will be reporting those cloud types at the 0Z hour. So enough about clouds. Let's look at the weather. It's hot here in Texas. I opened up the box to get a package from UPS, and there were about 50 ladybugs in our UPS drop box. They're starting to come out again. They think it's February because we've got these temperatures here running 5 to 10 Celsius above normal, which is about 15 Fahrenheit degrees. And some of that really warm air is making it all the way up into Manitoba and Nunavut, way up there. And this little slug of air is actually going all the way almost to the North Pole. So we're seeing temperatures on the ice pack coming all the way up almost to freezing, like 20s and 30s. But fortunately, no, we're not going to melt the ice pack from that, but it is running a little bit above average. But we got a little bit of cooler weather that's going to start moving into Texas over the next couple of days. And let's start out with doing our temperature analysis or thickness air mass analysis. And remember, we're looking at thickness right here. Thickness is kind of like an average of your density or your temperature in the lowest 5 kilometers. Your thickness can be any different layer, really, but we're doing 1,000 through 500 millibars, which is basically surface on up to 5 kilometers. And that's ideal for finding fronts. And we try to keep our fronts to the south part of this packing that we see here. You can see some more packing out in the Atlantic. And likewise, we keep a front to the south of that. So there's probably one way down in Cuba. But the one in the plains is looking like this. And we've probably got a little bit of a dry line possibly extending down into Texas. We'll have to take a look at the surface chart for that. But this is confirming from the NAM model that we should have a front moving through Oklahoma City, through Childress, through Abilene, and possibly Midland. So we're going to look for that when we do our surface chart. And then further out west, we can see another system coming on shore there. Most of the thickness packing looks like it's way down in California. So we may be looking at a warm front kind of like that, maybe. And then what we have north of there is going to be an occluded front like that. See, there's going to be some analysts and some stations, maybe the Weather Channel or something like that, they might draw the warm front way up here. Just, because it kind of fits with the pressure analysis. But we can see that that's not supported by the thickness field. And that can be important because that can catch you unaware. If you think that the warm front's up here and suddenly there's weather way down here, it's because you missed the front that's way down south of you. And of course, this is the main baroclinic area right here. We're looking for new cyclogenesis right there because the tighter thickness packing is in this area, and we know that the front is through this area. So that completes our air mass analysis. So let's look at our surface chart and see how that all ties in. This is the last hour surface chart. Let me get that centered for you real quick. Okay, so we have Oklahoma City there. There's Wichita Falls, there's Childress, and here's Abilene. So yeah, this matches up very well with the NAM and the NAM model initialization. You can see that front coming through Chickasha right there. Northwest winds gusting to 20 there, contrasting with south winds here at Pauls Valley. Likewise, you can see an air mass contrast right on Wichita Falls, or maybe just northwest of there, maybe something like this. And then this looks like bad data here. I'm not so sure about this one. That looks kind of weird too. But probably we're looking at the front, something like that. So how do we resolve this? Well, we can just head on off to the UCAR weather analysis website. And I'll just pull this up very quickly, and there's the Abilene sector. And they pick up a few of the Mesonet stations, the Texas Tech Mesonet sites in this area. And that tells us that maybe the front is a little bit, yeah, it's probably a little bit further north, around Post, Texas, around Aspermont. But that south wind there is definitely not supported. So, yeah, these are going to be bad data. So this is the new front on the way into North Texas tonight, and we're going to see changes with that. What about a dry line? Do we see a dry line? Maybe. Looks like Abilene's got 39 for a dew point here, 58 there at, well, that's Graham. This would be Throckmorton, I think. Yeah, so, yeah, probably a very weak support for a dry line right through here. So how would that connect with our front? Probably looking at something like this. So this dry line here represents the western periphery of the tropical air mass, which is located out in this area. And then the remaining question is, where's the moisture axis? Well, we can take a look at the dew points and look east and west and try to find where the highest dew point is. And yeah, we find it around Temple. We check east-west through Dallas. We find it around Greenville and Kaufman. So probably like right in here is where the moisture axis is. And that's supported pretty well by the cloudiness field. We don't have any marginal VFR ceilings. We don't have any blue or red colors except for this one right here. But the general area of broken clouds, that pretty much follows this moisture axis pretty well. So this is going to be the most likely area for any development as that front comes through. And we'll watch for that over the next few hours, because we are expecting some thunderstorms to develop along I-35 and towards East Texas over the next few hours. And I'm probably going to do a special severe weather live cast later tonight if we see storms going up, and I'll probably start that live stream, so you might want to check back in later if you want to take a look at that. Okay, what do we got up next here? We're done with that. Okay, yeah, let's look at our upper level charts. This here is the 500 millibar, no, this is the 300 millibar analysis. This is up at 30,000 feet. Looking at heights, winds, and the colored things, these are isotachs. So where we have the purple and white shading, that's going to be where our jet is. So basically our polar front jet is running something like that. And if we look very carefully, we can find a subtropical jet well to the south. And normally the subtropical jet has kind of an anticyclonic curvature. So that would be a good indicator of that. So there's a little bit of that going on here in South Texas. If we bring up the 200 millibar chart, Let me bring up SPC's chart so I don't waste a whole lot of bandwidth here. No, SPC doesn't have the 200 millibar chart. That's a shame. I'll have to go to another website. Let's see, who am I going to pick? I'm going to go with... Let's try UCAR. Yeah, that gives us some plots here. That's good for just a quick look. So this is the 200 millibar chart. This is up at 39,000 feet. In this time of year, that's going to be way up in the stratosphere. But we can pick up a little bit of that subtropical jet way down here in the Rio Grande Valley. And we've got 80 knots with that. So that's the subtropical jet, and then the polar front jet. We can see that well up here in Texas and in the Midwest. And then that brings us to the 500 millibar chart. This is where we find a lot of the good diagnostics for dynamics. This is the GFS 0Z chart, so this would be about 1 hour ago. And this is showing vorticity. This is where we have the strongest curvature and cyclonic shear. And this is showing a very large shortwave. Maybe we'd call that a major shortwave from eastern Nebraska down to about Midland, Texas. And then embedded in that, we might find a couple of smaller spokes of shortwave energy. So maybe something like that. There's many different scales in this field. And sometimes these smaller waves, those can be very important for initiating storms. And so what we're seeing here is positive vorticity advection in this area. This is where we're going to expect to find things destabilizing in the mid-levels of the atmosphere. So we're talking about cap removal and steepening lapse rates and that kind of thing. So at this time, we're looking at the air mass over North Texas and Oklahoma being worked on by this approaching trough. And then the mid-level jet, we can find that here, not only by the wind plots, but also by the channel, the vorticity channel between the very strong cyclonic vorticity and the neighboring anticyclonic vorticity. And the jet falls right in that channel, kind of like right in the gutter there. Okay, what do we got next? Let's take a quick look at the HR, the high resolution rapid refresh. This is a very cool model. This is kind of like the rock on steroids. This model is run every hour, and you can find that at rapidrefresh.noaa.gov. And this is a good tool. It's a non-hydrostatic model. It's good for mesoscale forecasting. And it's got some pretty neat things like simulated radar. So what is the radar going to look like over Texas at midnight? Well, let me refresh this, because I think we've had some new data come in. Okay, let's see. Here's the 01Z. Don't have that all in yet. But yeah, we have the 0Z data in. And this is making use of some of the radiosonde data. So this is good. So the picture that this is showing across Texas, as far as reflectivity at midnight, it's going to look like this, sort of. And this is kind of like a quick... I guess you would call this just kind of a approximation of what the radar should look like. I do need to warn you not to get too dependent on this stuff, because I've seen some very huge errors with some of these fields. Mesoscale forecasting is very difficult for these models still, so there can be a lot of errors. But the general pattern that it's showing is a line from Texarkana all the way down to Austin, kind of a scattered line of showers trying to develop. So what are those going to do over the next couple of hours? Let's check out 2 in the morning. Yeah, now we've got stuff going from Crockett down to College Station and down to Bastrop, Texas. So this is suggesting we may have a brief window of severe weather, maybe in this area right here. We may see a severe thunderstorm watch box go up for this area, maybe later on in a couple of hours. And if we do get storms going in this area, I'll probably start the channel up and we'll follow them. If not, then, we'll wait for a different day to do that. But on the backside, we can see that cold front coming in right there. So that's the push of cold air, and this is the forced convection along the leading edge of that cold front. Okay, so that's a quick look at the rapid refresh, high-resolution rapid refresh. I might go into detail on that in an upcoming webcast. But yeah, this is one other thing I want to show you. This is a good way to tell if the model is accurate or not. A good way to tell if it's on track. Let me bring that panel back up since I accidentally shut that down. So I'll click on SC for South Central US. Bring up the 0Z run. Then I'm going to click on 01Z because that's the current time. So, okay, let's shut that down. Okay, so what is the panel? What is the presentation that's showing? We're going to compare this to the radar and see how the high-resolution rapid refresh model is doing. Well, we're showing around Paris to Sulphur Springs, down to Emory, kind of an area of thunderstorms, another area of thunderstorms south of Palestine, and another little area of showers around Round Rock, Austin, and Taylor. Is that what the radar shows? Not quite. Let me outline those areas real quick. The HRRR showed an area here, and another one here. So already 1 hour out, there are some differences. So this is showing you that the model is not some kind of holy grail. It's kind of a tool you have to use judiciously. And what we're seeing here is that this line here near Sulphur Springs and Emory and Greenville, this is starting to come together. So what we're going to look for is maybe a little bit more filling of this area over the next couple of hours. So you do have to go kind of back and forth between your products and kind of improve them and, kind of like I showed you, use the radar and apply that to your high-resolution rapid refresh model output, and that'll give you an adjustment, and you can kind of improve your forecast that way. Let me get a quick drink of water, and I'm going to come back and read the chat, so give me just a second here. Okay, much better. All right, let's see here. Let me just check the chat over and make sure there's no problems. I got a question about La Nina. Yeah, we've got a very weak La Nina episode, and there's not much to say about it. We're just going to be kind of in a weak La Nina for a while, and then it should, I think they were going to bring it back to an El Nino later next year. I don't think that'll really affect our weather too much. We've got the northwesterly flow kind of predominating. There's no block in the Greenland area, so we're not getting the very cold Arctic outbreaks that we normally get during a La Nina. But things are kind of dry in the south U.S., and that's about what we would expect. So it's kind of on track, and I think this pattern is going to kind of stay with us for the next few months at least. Let's see here. The HRR is also deadly inside 12 hours. Okay. Oh, yeah. Hi, Jason Boggs, and hi to Mike and Ron, the usual guys, and Sarah and Alexei. Yeah, it wouldn't be the same without y'all here. So I'm glad you were able to check in with us. So let's go ahead and get into the forecast, since we've gone on for almost half an hour here. Okay, let's get this centered here. This is the GFS forecast for about right now. This is the 18Z forecast for right now. So there's the fronts very quickly. Actually, I think the warm front is a little bit further north, maybe like that. Okay, so what's going to happen tomorrow? We're going to see storms moving eastward overnight into the Mississippi River Valley. What happens tomorrow when you check in for the WEBCAST? Well, when you check in, I click a random button and something pops up. But let's see here for 0Z. Here's what the presentation is going to look like tomorrow. Going to have low pressure over Illinois. And it looks like our front is kind of washed out a little bit. You notice the thickness gradients, they're very broad across the central and eastern U.S. And they're a little bit tighter in Nevada and California. So this suggests that our front, like I said, is kind of washed out a little bit. Maybe kind of a weak, I don't even know where that warm front would be, maybe something like this. Or it could even be a little bit further south because we've got 3 thickness lines like that. So that's kind of a mystery in here. But we've got the lee side trough developing in Colorado. And further out west, I think I've lost my place here. Let's go back. Okay, so lee side trough in Colorado and Wyoming. And then it looks like we've got a little bit of high pressure developing into California and Nevada. So we're going to get some clockwise flow around that. So that'll give us some cold air advection into the southwestern U.S. So we're probably going to see a little bit maybe of a boundary in Arizona. We'll have to kind of watch this area. This could be an area of frontogenesis. And, wow, we're up to Thanksgiving here. And I will be doing the webcast on Thanksgiving, and when we do that, we will have a large high-pressure area. It's either a plateau high or Pacific air coming in, probably Pacific air. That's going to be dominating most of the Rockies, and we'll have some cold air advection coming down the east side of that into Texas. So we should get a reinforcing shot of cool air. That's it on its way down here. And then pretty quiet across the eastern U.S. And then when we see you on Friday, going to be looking at high pressure across Texas, kind of cool. A little bit of upslope conditions in the Big Bend area of Texas right there, so maybe a few clouds around San Antonio and Houston. Looks like some cyclogenesis up in Alberta, so lee side trough developing again in the Rockies. And here comes another Pacific system coming inland. For Saturday, still looks pretty quiet across the U.S. High pressure moving eastward into the southeast U.S., starting to get a little bit of warm air advection in the Central Plains. Here's our next Pacific system right here. And we can see a little bit of a front like that coming into Las Vegas, into Imperial, El Centro, Yuma. Then by Sunday, that emerges into the plains. And here we go with our next system coming into Texas. And I'm not too sure where our warm front's going to be, maybe something like that. And then let's see, going into Monday, looks like another chance of severe weather here in east of I-35 in Texas. Okay, so this is going to be our map on Monday. And that looks to be a very potent area of cold air advection, probably a very strong cool down in Texas. This is Monday the 28th. And that pushes rapidly through the southern U.S. So there goes our cold front, and this looks to probably be bringing a chance of severe weather to much of the southern U.S. And let's take a look at those dew points for next week. You can see this time around, tonight and tomorrow, 60s only reach southeastern Oklahoma and Little Rock, and then you can see those 60s here, they recede into Mississippi and southern Alabama. But next time around for next week, look at that, they get a lot further north. And actually, I don't think that's, I think we get another surge, do we? Yeah, there's another shot coming in on the 6th. And I'll just show that to you real quick. That looks to be a better surge in moisture. Actually, that doesn't look to be all that strong either. We do get some 70s in East Texas, but it looks like even that doesn't make it very far north, maybe to Birmingham. Definitely 70s along the Gulf Coast. That's going to be significant, but it doesn't look like the higher dew points are going to make it too far north. So we'll just bring this forward real quick. Okay, December 1st, large area of cold air advection into the central and eastern U.S., and 540 thickness line all the way down to Dallas and Shreveport. So that's going to mean highs in the 30s and 40s across Texas. Very cold start to the new month. And then cyclogenesis in the southwestern U.S., upslope flow. This looks like to be a period of some very cloudy and dreary weather in Texas and New Mexico. We're talking December 3rd and 4th. And we're starting to get way out there. December 6th, next system along the Gulf Coast. So looks to be pretty active in this area, southern U.S., at the start of next month. Okay, I think that's about all I got here. I appreciate y'all watching, and let me check the chat over and see if there's any questions or anything. If I miss your questions in chat, forgive me, because I got like 15 windows open, but if I see one, I'll try to catch it next time. Anyway, I appreciate you watching, and I hope you'll join us tomorrow at 8 o'clock, and I'll see you then.